Okay, good morning, class. Today we're looking at measurement. At this point, we're looking at changing of dimensions. We spoke about changing the dimensions in grade 10. Okay, so here we are told that this is a revision of work that you did in grade 10 on scaling objects. If a shape or objects are scaled, similar shapes and objects that has the same proportion as the original but different sizes result. Okay, so the shape will look the same, however, the size of the shape is um, different. However, the shape is enlarged or reduced by a same factor there. Okay, so the shape will basically look the same. If a 2D shape is scaled by a factor of k, then similar shape is created. This shape has all of its dimensions at a ratio of k to the original object. The ratio of the corresponding areas is k squared. So area is 2 dimensions, that's why k squared. When object is scaled by a factor of k, then the volume, so the volume of the object will be scaled by a factor of k cubed. Okay, and we spoke about this and we said that a k can be a fraction as well, however k can't be a negative number. Okay, this we said this example is on the electronic version, however it's not on the in the textbook. Okay, so we look at the example on page 268. All right. So we are told here a cone with a radius of 5 is glued to the top of the cylinder, also a radius of 5. The perpendicular height of the cone is 3 and the perpendicular height of the cylinder is 16. As I work with two decimal places, calculate the outer surface area of the figure. Okay, so we'll be looking at the surface area of the figure. So number 1. So the surface area will be this here, the cone, outside of the cone, plus the outside of the cylinder. Remember, is that part as well. Okay. So how do we calculate the area, the total surface area of a cylinder? The external area of a cylinder is going to be perimeter of base. It's a circular base, so it's 2 pi r times height plus twice area of base. Okay, so the area of this base is going to be pi squared. Twice area of base is going to be 2 pi r squared. So if you look at this base here, okay, this is at the bottom of the shape. Okay, remember that the cone is glued on top of the cylinder. So would I consider that there? No. So instead of having twice area of base, I'm going to only consider the base once. Okay. So I'm going to take one of it away there. It's going to be pi squared. Now we're going to look at the cone. Okay, now how do we normally calculate the surface area of a cone? It's going to be pi rs, which is the slanted height, plus the area of this is going to be pi squared, the area of the circle. However, the circle is not exposed to the external, so I'll drop that as well. Okay. People, the textbook shows this as a 5, it should be an S. Okay. So let's go. To calculate the slanted height, so firstly we go 2 pi, the radius of the cylinder is 5, the height of the cylinder is 6, plus pi, the radius of the cylinder is 5 squared, plus pi, the radius of the cone is 5, and the slanted height is what we must calculate. Not so. So the slanted height squared is equal to 3 squared plus 5 squared. 3 squared plus 5 squared is 9 plus 25, which is 34. So the slanted height is going to be the root of 34. You all agree with that? So that will simplify into state 60 pi, 25 pi. 60 plus 25 is 85 pi plus 5 root 34 pi. Okay. Let's work that out. So it's 85 pi. 85 pi plus 5 root 34 pi. 85 pi plus 358,63. Is that correct? Huh? They didn't work it out. So add it together, see what they get. So they got 92,59 plus 300.63. So that means rounded off values. It's not so. Okay, so the answer is right. Just write it in the book there. $358.63 or the value you guys got it. Okay. It's 358.60 centimeters squared. Okay. Let's look at the second question. The second question says, calculate the volume of this figure. So what I'm going to do is I'm going to take this off. Yeah. I'm just going to keep the totals here. I think we'll probably need the total for that. Okay. Let's look at number 2. The volume. How are you going to calculate the volume of this figure? The volume is going to be the volume of a cylinder. Okay, how do you calculate the volume of a cylinder? Area of base, pi r squared times height. So it's pi r squared times height plus, how do you calculate the area, the volume of a cone? The third, area of base. How do you calculate the area of a circle? Pi r squared times your perpendicular height here. So it's third area of base times height. Okay. So that will simply be pi. What's the radius of a circle? Of the cylinder? It's 5 squared times the height, which is 6. Plus the third pi, the radius of the cone. 5 squared times the depth, which is 3. Okay. So that will give us 25. 25 times 6 is 150 pi. And that cancels, leaves you with plus 25 pi. Gives you 175 pi, which is 175 pi, 549,78. Is that correct? 549,78 centimeters cubed. So any confusion there? Huh? Fairly simple, no? Right. Let's look at number 3 now. Number 3 says calculate. Now, the figure says, this question says, this figure is increased by a scale factor of 3. Okay. So now we're going to let K be 3. Okay. It's now your number 3. Scale factor of 3. Calculate the outer surface area of the new figure. So the total surface area now is going to be K squared times the original surface area. Okay. Why K squared? Because why it is 2-dimensional. Okay. So if K is equal to 3, the surface area is going to be 3 squared times the total surface area, which is? Sorry. Come down. As in. So, nope. Wat gaan we met TikTok zeggen? Total surface area? So I just say 358,63. Okay. Now put that in the calculator. Say 3 squared multiplied by 358,63 gives you 3,227,67 centimeters squared. So instead of multiplying each dimension here by 3 and then reworking out the total surface area, that's going to be a quick way out. Does it make sense, people? Right, and then the next one. It says, calculate the volume of the new figure. So how do you calculate the volume? The volume will be, how much dimensions? 3 dimensions, not so. So the volume is equal to K cubed times the original volume. Okay. So what is K in this case? 3. So 3 cubed times 5, the volume, the original volume, which is 549,78. Let me calculate this. So 3 cubed times 549.38. 78. That gives us an answer of 14,844.06 centimeters cubed. Okay. Fairly simple, no? What if they said your K factor was 7? What if the K factor was 7? Then I would have just said 7 squared times the original surface area. Can you see that? What would the volume have been? 7 cubed times the original volume. Okay. What if the K factor was 3 over 2? 1.5 times the original dimensions. Then it's going to be 1.5 squared and 1.5 cubed for the volume. You guys understand? What if it's reduced by a factor of 2? Then your K would be a half squared. Can you see that, people? So reduced by a factor of 2. And this would be half cubed. And so on and so on. You guys understand? Yes, Michael? Because you are dividing, it's getting smaller. So if you take this and half it, what do I get? 3. Reduced by a factor of 2. So how do we get that? We say a half times 6. This would have been a half times 5. That would be a half times 5. That will be a half times 3. That is why K is now going to be a half. Okay, you guys understand? That's how it goes. Okay. So with that, you should be able to do exercise 8.4. Alright? And that brings us to the end of this chapter. And this is also our last lesson for the year. Okay. Of your syllabus. We have finished your old syllabus now, no? Yes. Now we're going to start past papers. We're going to choose a paper. We're going to start past papers for your cycle test and for your final exam now.